So this is a screencast of how to download and work with the Jupyter Notebook. So during the classes, I'm going to demonstrate some Python code in a notebook, and after the lectures, I think it's a good idea for you to actually download the Jupyter Notebook and work with it and go through it. So, sorry, there. What I did there is I clicked on the Jupyter Notebook. It takes us to this link. So you don't have to, if you have another way of running Python, if you want to run it via a Spider or PyCharm or some other system, you can just cut and paste. To actually download it, so you can cut and paste. To actually download, which may be very more convenient, you click on this raw button here, raw. You click on that. We end up. This is what that's sort of what the computer sees of the notebook, and so you save it. One of the annoying things about the Chrome, it adds a .tx thing at the end, a text file end, which wasn't in the original file on the web. What you really need is .ipynb, so there's another complication. You need to store the file someplace where the notebook can find it. And in this place I put it on the desktop, so my Jupyter Notebook's running on the desktop, and you have to be able to get from the Jupyter Notebook to the file. So let's save it. Okay, you'll set up a Jupyter Notebook in a different system. On my Mac, this is the way I get it to go. So you'll go via the Anaconda on the Windows system. And so here we have the Jupyter Notebook, and here are the different files you can see, and these are on the desktop where I saved it. So one of the kind of annoying things is this .tx things means that when I click on it, I get this, which is what this is the kind of text version. And so to get rid of this, you have to rename it. I mean, you can do this in the folder. Take away the .txt, and then it has .iypnb. If you do that, then close this tab. And now when we go back to the thing, because the file ending is .ipynb, the Jupyter Notebook knows this is a notebook and it's ready to run it. And then we click on it, and here we go. So now this looks like this is my running class. So a notebook is organized by cells. You can click on cells, and it highlights. So this is a text cell. This is a Python cell. You click on run. So we had here a variable a equals z equals 2, and then we can print text out hello world, and we can print out a equals 2, and then do an addition. So we're using Python as a calculator. Okay, and then here's some documentation for it. You can actually, if you double click on a text cell, you can actually see the underlying text, and there's some way to nicely format it if you run it. So with the Jupyter Notebook, you can add cells if you need to. So everything runs in cells. Insert cell below. So I've inserted a new cell, and I can then print something. Right, and there's different kinds of cells. So if you want to insert, and say insert a new cell below, and I want to write some text, if I convert this thing at the top to text, well, it's called Markdown, I can, so this cell here now is a text. So when I run it, I see some text. So during the first lecture, I went over some, okay, so here we have some different, so this Python code doesn't do anything when we run it. But there's different variables, and variables can have different types. So here x equals 10, because 10 is an integer. Python knows that x is an integer. So y here is set to 3.45, and then y knows that's a floating point. It means something with a decimal place. And then if you have z equals hello, you see the double quotes, and it knows that z's a string. And then it can also have true and false in the jargon, that's a Boolean. And it just means when you do different operations, different things will happen if the variables are different types. So sometimes you want to collect together variables in lists. We want to collect together variables if you have a number of people and you want to collect together their ages, say. So there are some data structures to do that. So one of the simplest is called the list. So if we print this off here, so this square bracket notation creates a list. So we created a list of 23, 14, 6, and 8. If we print the whole list out, we get this thing back here, 23, 14, 6, 8. But if we use this square bracket notation 0, this will give me the first element. Square bracket 1 will give me the second element. And there's also a len function that will tell me how many elements are in the list. So, and then there's a whole bunch of other methods you can use to find out information. And you can also update the list. So if you want to set the second element to 0, you can do that. And you can see here it's had some effect. And there are many other, so, collecting together variables is kind of important when you do any analysis. I mean, this could be like line, text on different lines. There are a couple of other data structures. A very similar one is called the tuple. And this is essentially a list that you can't change, at least the most basic thing. So here, instead of having square brackets, I use open brackets here. So let's run this, see what happens. Let's run again. And you can see when I print out the tuple now, we get Jane and Roger, and I get the first element still now with the square brackets. Now, one of the main things with a tuple is so like with a list, we could change it. So if I wanted to change the first element to unknown, I actually get an error. And the reason the error is because the tuple just, it's like a list, but you're just saying, actually, I don't want to change this. So you can't change anything. If I were to convert this into a list, doing this, so coming into square brackets, then it's perfectly okay to modify the elements. Okay, and this is see what I'm doing here is I'm also exploring a little bit. So the advantage of Python, you can play around a lot. If you don't know what something's doing, you can print it out and examine it. So another basic thing you can do with Python is we have our list here, 23, 14, 6, 8. And what the syntax is, we want to loop through it. So we can loop through every element. That's what this syntax means here. V underscore. So there's a loop. So we go loop through first element, second element, third element, fourth element, and then print it to the screen. And you'll see this syntax all the time because once you have a list, usually you want to do something with it. Okay, another useful kind of syntax. You want to do if something, then do something, otherwise do something else. So in this statement here, I have a variable x equals 10. And if I want to write x greater than 0, it's a test for positive, which I might want to do. So if I run it, I can see x is positive. If I try converting x to -1, then I run it, and it prints out x equals negative. So this is quite often. So if you want to execute some kind of code under some condition, then this is the kind of way to do it. Okay. And you can also, so this syntax here, name equals input. So it's going to print out, enter your name, and it's going to put a little box. So that's what, so input means write this string out and make a little box to take input. And you input your name, press the new line, and then it goes to the next line of the text, which is write hello, then Craig. Okay. And there's just one of the things is, which is just a bit confusing, is when this input assignment, so it brings up a box, but actually it always brings back a string. But if you want to actually do some kind of calculations with a string, like multiply it by 2 or something, you have to convert it into an integer. So here's what this command here is doing. The int takes a string, converts it into an integer. So now, so if I put in my age, because I've converted the what was inputted into an integer, I can actually do calculations with it. So I can add 1. So it tells me next year I'll be 56 years old. So putting it all together, how do you do little programs? So if you want to compute a mean or something, you can, so you have a list, you have the data in some list, and then you want to compute the mean, which is the sum of the numbers divided by the number of numbers. So you have 67, 80, 39, 36. So I have this variable here to accumulate. I set it to 0. My x loops through the elements in the list. So the first time it goes through the loose, x will be set to 67. The next time it's set to 80, then 39, then 36. And then this plus equal means I add in x. And then at the end I divide by 4 to give me the average. And when I run this, I get 55.5, which is the same as my hand calculation there. Okay, so this is starting to put together bits of, so we started with variables, we had something on loops, and often the data will come in some kind of data structure such as lists, and then we can just do simple calculations like compute the average of the numbers. Okay, so the only thing I wanted to show you, sometimes the code will get a bit stuck, and you can stop the code by clicking on this restart plus clear output. And so, I mean, so the Python's running in the background, but if you see something here where the things start and nothing happens, if you click on restart and clear output, it'll stop Python, and then you can go back and try again. Okay, that's all I wanted to say.